Okay, so we have one more page, right? We're here? Because I think we finished the others, didn't we?
Yes.
All right. So it says we want to consider the function y equals x minus 1. Draw a graph of y equals x minus 1 on the interval 0 to 3 and use it to evaluate. Okay, so we need an interval 0 to 1, 2, 3. And let's see what we're down here. This. So if this is the line y equals x minus 1, what is our y-intercept? -1. So we have a point here. And when x is 3, y is what? 2. Okay? So we're here. This is 1, 2, 3. Hey! Oh, goodness. Okay. Well, you didn't tell me that. All right, so let me draw my line here. It looks something like this. Okay, close enough. Well, you only have to draw from those 2 points, but okay. So this is what we have. So if we want to, it says draw the graph and use it to evaluate. So remember, if you're going to integrate, what are we looking for when we integrate graphically? We shade. We're looking for the what under the what? The area under the curve, right? So it's the area bounded by the function and the x-axis, bounded by this function and the x-axis, all right? So the part that's bounded by this function and the x-axis from 0 to 3 is this right here, okay? We're looking for the area that is bounded by this function and the x-axis, but right now we're only looking on this first one from 1 to 3. It's bounded, here's the important thing. It is bounded by the function and the x-axis when you have a dx. If we have a dy, it's bounded by the function and the y-axis. So when we're going from 0 to 3, it's whatever is bounded by the function and the x-axis. That's why this is under it. Does that make sense to you? Because it's bounded by this function and the x-axis. Is that what you were asking? Okay. Does that make sense? Okay, so that's how you know if it's above or it's like, where is it bounded? This is the shading. This is the part that we're looking for. All right, so in this first one, we're looking for, and I want you to think about this too, because this is very important here to think about this as like as a concept. Area has 2 dimensions, right? That's why up until now, your area, the units on your area has always been square, because it's been like feet times feet, because you have 2 dimensions, right? Now we figured out the other day, it's not always going to be units squared anymore, because our units may have been a ratio to begin with, but you're still multiplying 2 dimensions by each other. This right here, however we're going to come up with it in a minute, but this is it's the value of the function at whatever point makes sense for the area that we're doing, times the change in x. So you have a y value times an x value. Those are your 2 dimensions. Does that make sense to you? So whatever number we get for this part of our triangle is coming from being the value of the function. It's my y value. Whatever is this is my change in my x. In this first one, we are going from 1 to 3. So if I'm going to go from 1 to 3, the area bounded is just this triangle right here, right? So all I'm really doing is finding the area of the triangle. I know that the area of a triangle is 1/2 base times height. So 1/2, the base is the change in x. I'm going from 1 to 3. So 3 minus 1 is 2. 1/2 times 2 times the height of the triangle, which is coming from here. And it's the 2 also. Right? 1/2 times 2, which is going to equal what? 2. Okay, make sense? All right, we good? All right, so now I want you to do this one. Okay, so we are going from 0 to 1, so it's the area of this triangle right here, right? So I'm going from 0 to 1. It's a triangle, so I know it's 1/2 times something times the function value, or I'm sorry, let's do the base first. The base, which is the change, because you think 1/2 base times height. I'm going to use this as the base of my triangle. That is the change in x. So that's 1 minus 0, which is 1, right? Times the function value, which is what? -1. So your answer is -1/2. Okay. So remember, I tried to use the word, say, we're finding area under the curve. This is an area concept, so we can have a negative area. Below the x-axis is a negative area. Just like if we're going left, our velocity is negative. Remember those types of things if you're going left or right, up and down? So anything under the curve is going to end up being negative, and it's because we're using that negative function value there. Okay, we good with that? What questions you got? All right, so if we look at this third one, we are going from 0 to 3. 0 to 3, so it's all of this. So it means I have two triangles that I'm going to add together, right? And we've already found both of them separately, right? So that means that this is going to be the first one, which is -1/2, and I add it to the second one, which is 2, which is going to give me 3/2. And if I didn't already have this information, then I would just find them separately. Okay? It's just simple area. Just pay attention to where it is, and that helps you with the negatives. We good? We okay on all three of those? Ask me a question. All right. So what's the difference between this next one and this first one? Exactly. So this one we're going from 1 to 3, so our change in x is 3 minus 1. This one goes from 3 to 1, so our change in x is 1 minus 3. Okay, because we're going the opposite direction. Does that make sense? You have to pay attention to that as well. So if I'm going to the right, my change in x is positive. If I'm going to the left, my change in x is negative. You with me on that? All right, so we're going from 1 to 3, and so let's see if I can. We'll get, this is equal to 1/2. So the base length is my change in x. That is going to be a -2, right? Times the function value, which is 2, which gives me a -2. So it is possible for the area to be above the graph and be negative. Okay, it has to go with which direction you're going. So you got to pay attention to the order of the numbers as well. Okay, let's go from bottom to top. So then what do you think? Let's look at this last one. 0. Why is it 0? Because there's no change in x, right? Okay, the function value at 1 happens to be 0, but even if it wasn't, your change in x, that is 0. So 0 times anything that we do is just going to be 0. Okay, there's no area there. What questions you got? You good? Okay. All right, so I'm going to give you an exit ticket on this, and I want you to work on it individually for a few minutes, and then I'll let you put your heads together. But for a few minutes, I want you to do this 100% on your own. It's going to be easy. Good.